Okay, so if f is a continuous random variable, I mean x and y are um, f of x comma y is a continuous function, and if you have the joint density function for a continuous random variable, how do we solve the problems? We have seen the theory in the previous videos. Okay, how do you solve such problems? When f is continuous? Obviously, one thing I made you clear in the previous videos is when it is continuous, then we are going to integrate. How are we going to integrate? The function is being given. Let's see according to the question how we are going to do. The first question is p of x less than 1 intersection y less than 3. How do I do it? Just see here. Integral. Actually, every function ranges from minus infinity to plus infinity. But wherever it is defined, there only we will take, like how we used to take for a single random variable. Um, mm, for a single random variable. Okay. For a single continuous random variable. Okay. Yeah. So I'll be writing like this. The limits are known to me. Dx, dy. Now see here, actually from minus infinity to 1 only, f of y variable is defined. No, x variable is asked. Y variable is asked from minus infinity to 3. Actually, the question is this. But clearly you can see here, x is defined only from 0 to 2 and y is defined only from 2 to 4. Okay, so accordingly I have to modify the limits for the double integral. Okay, all of you are aware of double integrals. Anyways, if needed something, how to shade the region and all, I shall let you know. But as of now, it's a simple problem of just evaluating a double integral. Okay, yeah. So, minus infinity to 0, nothing exists. Minus infinity to 0, nothing exists. From 0 only x is existing. Similarly, minus infinity to 2, nothing exists. From 2 to 4 only y exists. Okay. So, 6 minus x minus y. dy dx actually it is dy dx because I know these are the limits for y and these are limits for x. Okay. Once you integrate it, you will be getting the answer. I should know basically for a joint probability distribution, I should know how to write the notation. Once notation is there, you will do the job very easily. Okay, your job would be done very easily. Now coming to the second question which is very interesting. X plus y less than 3. So what I should do is anything. One variable should be a constant and the other variable should be a function. So what should I do? Actually, see here, I can clearly see the region. X is ranging from 0 to 2, guys. 1 and 2. Y is ranging from 1, 2, 3, 4. From 2 to 4. So I can clearly see this region. See, this is my region actually. Okay? Yeah. So in that, whatever area has been asked, I am finding out. Now here he has given me a condition. So how am I going to take one variable in terms of the other? Okay. Now y would be what? 3 minus x only, na? Right? From where it is starting? It is starting from 2. Y is equal to 2 to 4. This is, guys. And this is x is equal to x is ranging from 0 to 2. Okay, I don't think this line should be there. I'm sorry. This line should not be there. Okay, it's from, it's from 0 to 2. Okay, so it's something like this. So, y is ranging from 2 to the maximum value is y minus x minus 3. I'm sorry, 3 minus x. Y value in terms of the relation that's been given to me is 3 minus x. 3 minus x and x limits are from 0 to 2 actually 0 to 2, yeah, but then I'll be taking from 0 to 1 only. You can just see x plus y less than 3 means what? The sum of x and y should be less than 3. What are the options that I have? 0 and 3 is one option that I have. X can be 0, y can be 3. X can be 1, y can be 2. X can be 2 and y can be 1. Of course, this is also in the range only, but then equal to not equal to things are there. Any other combination, guys? Yeah, I can have 3 comma 0 as. Okay. So, but 3 comma 0, x limits are not from 3. They are ending at 2 only. Okay. So, that is ruled out. Maximum value x can take is what? Maximum value x can take in this is yeah, 1 this only. Why? Because again 2 is not included, guys. If you see the limits, 2 is not included again. See, 2 is not there. Less than 2 only is there. Okay. So the maximum value x can take is 1, 0 to 1. Okay, like this I will take. And then the integrand I'll be substituting 1 by 8 is 6 minus x minus y. Limits are for y and then x. I'll be integrating. Of course, I have the answer. I can just give it to you. You can just verify. 5 by 24 is the answer. Okay. Yeah. Now coming to the third one, which is conditional probability for continuous. P of x less than 1, y less than 3. Subject to the condition that y is less than 3. How I will take, just see, P of x less than 1 intersection y less than 3 by P of y less than 3. Okay. Yeah. So how will I take from this? Just see. X less than 1 intersection y less than 3. Okay. How I will take is x less than 1 integral 0 to 2 integral 2 to 3. From part 1 x less than 1, how I have taken is 0 to 1 I have taken. Okay. Yeah. 0 to 1 I have taken. And y less than 3, how I will take? It is starting from 2 and it is going till 3. Okay. So I'll be taking like this. I'll just write it for you. You can just see part 1 how I have taken. Okay. Yeah. So it would be what? Integral 0 to 1, integral 2 to 3. Excuse me. Excuse me. 1 by 8 can be written out 6 minus x minus y. Limits are for y and then x. So accordingly, I am writing. And accordingly, I'll get the answer. Okay, that's the numerator, by the way. Denominator would be what? Y less than 3. So for y less than 3, how I will take is, I have to take like this. All the x values from 0 to 2 I will take. And for all the y values till 3 I will take. Again the same function. 1 by 8. 6 minus x minus y dy dx. I hope it's clear. Okay. Yeah. This is the, of course, the favorite question to the examiner. 0 to 2, all the x values I am taking. But then there's a limit on the y less than 3. So 2 to 3 only I am taking. Accordingly, I'll evaluate. There's an answer for this. Of course, this denominator turns out to be 5 by 8. And finally, the numerator and the denominator together, numerator answer will be 3 by 8. So finally, it would be 3 by 5. Third answer would be 3 by 5. This is how I will calculate. Okay, I should do one more problem on continuous probability, guys. In the next video.